Good morning. Earlier, I discussed the installation of risers between the manifolds on each floor, as well as the entire air distribution system on the suspended ceiling structure. Now, we will discuss the installation of the heat recovery unit in the technical room and its connection to the system, that is, to the supply and exhaust ducts, as well as the intake and exhaust air channels. Welcome to the next part of the course, a video course about the installation of heat recovery ventilation. Judging by my outfit, it might look like we were here just the day before yesterday, but unfortunately, it's already autumn, and the first part was actually filmed in the spring, around February. Now it's November, but what's important and relevant today is that we're going to be installing the ventilation unit in the boiler room, in the technical room. Here we have a ReNet ventilation unit from the REQ Series V version. And this is how the packaged device arrives at the construction site. I know that as installers you don't read the manuals, but this is the manual for the correct installation of the siphon connection. Very often you call me for technical advice, saying the siphon doesn't fit. I ask, did you read the manual? No, because there was no manual, so I'm proving it. The manual is always placed on top, on the ventilation unit. In the package with the unit, that is, with the recuperator, you get a complete set of connection nipples. The filters are included. An additional F9 anti-smog filter. A dry siphon. A complete set of documents with the manual, the warranty card, and also the power cable inside. As well as gloves so you can freely install the ventilation unit. So that's the package that comes with the unit to allow you to install it in the system. So today, we're going to be hanging this unit in the spot that's designated for it in the utility room. Using the installation manual and the information it contains about how to mount the heat recovery unit on the wall, but most importantly, using the information about the installation space, which we've already preliminarily marked and measured on the wall, the key thing here is the distance from the wall. This is important because the Wi-Fi module is installed in the unit, so the Wi-Fi signal needs to have access to the card. So the first thing we actually need to install, using the wall mounting method, is the mounting bracket, just one. The manual also shows a second mounting bracket that is installed underneath. Why? Because on this mounting bracket, we have two holders. In two places, we can move the heat recovery unit away from the wall. So the bracket at the bottom is there to also move the bottom away from the wall, so that the device is properly installed, leveled, and aligned vertically. So the first thing we need to do is measure and properly install the wall bracket, both this one and the one at the bottom. As I mentioned at the very beginning, inside the box with the heat recovery unit, there is an instruction manual for installing the siphons. Just in case there are some people who might have a bit of trouble reading the instructions, I'm showing it here. On the siphon, there's a part that holds the gasket in place, and you need to unscrew it from the siphon to access the gasket. Only then do you install it at the bottom into the drip tray so that the condensate from the heat recovery unit can drain into the sewage system. So, let's show it one more time, okay? Here is the part that holds the gasket, and you need to unscrew it, remove it from the siphon, and only then install it onto the thread that's at the bottom of the drip tray. We already have the ventilation unit, the heat recovery unit, mounted on the wall. Now, once again, looking at our installation manual, we need to follow certain requirements regarding the length of the pipes, especially in the sections where the fan is located, that is, at the supply and exhaust. The pipe lengths where the fan is should be at least 50 centimeters, 500 millimeters, and in the other two places, like the air intake and exhaust, there should be at least 30 to 50 centimeters of straight pipe section. If that's not possible, we should try to use elbows, rigid elbows, that we can install on the heat recovery unit so as to minimize resistance, the resistance of the installation, especially here, in these sections where the fan is installed. So again, following the instructions in the section on installation space, we need to maintain those minimum distances, the minimum lengths of pipes, and then we can proceed further with installing the pipes and the system itself, that is, connecting the ventilation unit to the air distribution ductwork inside the building. Now we move on to installing the nipple. On to the ventilation unit. There are gaskets on the nipple, so it's important to install it correctly to ensure a tight connection. The nipple is made of EPP material, which is already an insulator and provides insulation at the connection point between the heat recovery unit and the installation with the pipes and ducts. But it's especially important, particularly where the intake duct is, to install this nipple correctly so that no air gets inside, because in winter, cold air flows through the intake, and where it meets the warm, humid air in a room like a boiler room, condensation can start to form. If the gasket doesn't seal properly, that water could get inside. And here, for example, on the filter inside the device, an ice block can form and block the airflow. So remember to install the connecting nipples properly so that the connection is airtight, not only to prevent air from getting in, but also to ensure there are no thermal bridges. When installing a nipple to a flexible duct, whether it's a metal nipple or a plastic EPP nipple, we need to make sure the connection is airtight, meaning the inner duct must be tightly connected to the nipple, but we also need to ensure the nipple is properly insulated. So, we need to pull the insulation over the nipple. I'll show you how to do it the right way. So, if we have a flexible duct, we cut the inner sleeve about 15 or 20 centimeters shorter, so that we can then fold the outer jacket inward to protect the wool from air. In other words, to prevent the possibility of water condensation. So, once we have carefully cut the outer sleeve and the inner duct to a shorter length, we will then proceed to try and install it. I use it for connecting and sealing, right? Between the duct and the nipple, I use butyl tape. Because butyl tape is more flexible than aluminum tape, which is what most people usually use, whether it's reinforced or not. At least wrap the tape around twice. And now, just to be sure that the duct doesn't slip off the nipple, we can secure it either with a zip tie or a clamp, meaning a metal band, right? So now, since we already have a very tight and secure connection, we carefully fold the outer sleeve inward, towards the garment. Under the insulation, under the wool. Or we can also do it this way. We can pull, for example, this sleeve. If we have another duct just like this one, we can connect it to the second duct so that this sleeve ensures a tight seal here, preventing air from getting in. Once we've done that, we hide the nipple inside the insulation, meaning inside the wool in the duct, so that later, when connecting to, to the intake, the exhaust, or to another element, or to the recuperator, the entire nipple is concealed within the layer of insulation in the wall. So that's how a proper installation of a nipple with a flexible duct should look. We have the installation prepared, meaning we have the EPS ducts mounted on the ventilation unit, the recuperator. We also have the installation mounted on the building side, supply and exhaust. Here, we actually had to make a crossover, meaning the ducts cross each other at a certain point, which is why we used an insulated flexible duct for the connection, precisely because of this crossover, to make the connection easier, but also to ensure proper acoustics in the ducts. So, using an insulated flexible duct will help reduce noise between the heat recovery unit and the distribution boxes installed in the building. But now, there's still the crucial matter of carefully connecting the coupling, specifically, the vital task of securely connecting the EPS duct to the flexible duct using a robust coupling mechanism. And we can do this in two ways: either, as we discussed earlier, install the outer sleeve, the duct jacket, over the pipe, and then pull the insulation over the coupling. Or we can do it the other way. In this particular case, we pull the insulation, which is the wool material, over the coupling, while the protective sleeve itself is carefully pulled over the EPS ducting. Break time equals 0.5 s/. Wrap it with tape to ensure it's airtight, so that no air gets inside. That way, water from the air won't condense between them on the insulation on the wool. So that's one of the two methods we can use here. Now we'll connect the pipes to the EPS ducts. And in this case, here at this project, there's still one more stage left, which is installing the air diffusers inside the supply rooms, where we need to set up supply and exhaust, and then carrying out the entire startup process using the Imprax app, meaning the whole process of commissioning the heat recovery unit. So I invite you to the next episode, where we'll be discussing and demonstrating these parts.